The box contains red marbles and blue marbles. The ratio of red marbles, so I'm going to write that out here, red marbles to blue marbles is going to be 8-3. Select each statement that could represent the number of red marbles and blue marbles in the box. And so there are 4 statements here, and the way we're going to solve this is we're going to make a ratio table. The way we do this is we set it up times 2, times 3, times 4, times 5, times 6, times 7, and then times 8. And so what we're doing is we're taking our values for red and blue, and we're going to multiply them by those numbers. So what we're doing is we're creating equivalent fractions here to see which statement could be true. So I can do 8 times 2 is 16, 8 times 3 is 24. So you can see I'm counting by 8s. 32, 40, 48, 56, and 64. So I did that just for red. For my blue marbles, I'm counting by 3s. So 3, 6, 9, 12, 15, 18, 21, and 24. And so you see here I have some statements that we need to figure out which ones are true and which ones are false. So the first one says there are exactly 3 red, and we can stop right there because we know that that is incorrect, so our first choice is out. The second one says there are exactly 64 red marbles, so I'm going to find my chart where it says 64, and there are 24 blue marbles, and so I know that I have the second choice is correct. Let's go take a look at the third choice. There are exactly 18 red marbles, and 18 is not even on my not even a multiple of 8 here, so I'm going to cross that one out. And last but not least, there are exactly 48 marbles, so we have that one, 48 red, and there should be 18 blue in the box, so that one checks out as correct. A board contains stars and triangles. The ratio of triangles to stars, so we're looking at triangles to stars, is 3-1. Select each picture that could represent the stars and triangles on this board. So same thing like we did in another problem, we set up a little ratio table, 2 times 2 times 3 times 4 times 5. I think that should be enough. So on the top we're counting by 3s here, so let's go ahead and do this. 6, 9, 12, and 15. And for stars we're just counting by 1s. 1, 2, 3, 4, and 5. So let's figure out ratios in each box, and let's see which boxes we could select. So in our first box, we notice that there are 1, 2, 3, 4, 5, there's 6 triangles, and then there are 2 stars. So let's go find our ratio table here. We notice that there are 6 and 2, those match. So our first box is a choice. Let's go and do the next one. So we have 2 triangles, and then 1, 2, 3, 4, 5, 6 stars. Remember, we're doing this ratio triangles to stars is 2-6. So in my first line, I only see 2 there, so let's go ahead and cross that one out. And last but not least, let's go ahead and count the triangles here. 1, 2, 3, 4, 5, 6, 7, 8, 9 triangles, and there should be 3 stars. So we go on a ratio table here. There's 9, and then there's 3. So you see I have 2 answer choices for this problem. The model is shaded to represent one whole. So let's go ahead and label that as one whole. And write a fraction, decimal, and percent to represent the shaded part of each model. And so let's go do the fraction first. So a fraction for model, let's label this model number 1. So I have 3 pieces that are shaded out of 5. I can represent that, if I was going to represent that as a decimal, I can multiply the top and bottom by 20 to get to 100. Same with that as 60 over 100. Or I can write that as 0.6, 6/10, or 60 hundredths. And I can also write that as 60%. Let's take a look at circle number 2. And so let's go and count up the number of pieces here that we have. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 total pieces. And how many are shaded? So we got 1, 2, 3, 4, 5, 6 that are shaded. So if I'm going to simplify my fraction here, my fraction simplifies to 2/3. And so 2/3 as a decimal, this is 0.66 repeating. And then my percent, I can write this as 66.6%, and I can repeat that, or you might write it as 66.7% if you round it. And this is how we do this problem. So now let's go ahead and figure out this problem, identify each statement as true. And so here we have a really small percent. And here we have a percent. This is the same as 25%. So you can see right here that we do not have a match. So first one is out. We can do the same thing for the second one. This is a really small percent. That's less than 1%. 2.5 as a percent is 250%. And so we know that these ones are out. So let's go and do number 3. So number 3, I already said this is 250%. Here's the reason why. The 2 is 200%, and then 0.5 is the same as 50%, and then we just add up our percents to be 250%. So we have a keeper. So what about this one, 2.5%? And we have 5 halves. Let's make 5 halves into a mixed number here. So 2 goes into 5 2 times with a remainder of 1. So we have 2.5. I can also write that as 2 and 5/10. So we have our second keeper. And then lastly here, 25 hundredths. If I write that as a fraction, 25 out of 100, the word percent means out of 100. So I can write 25 hundredths as 25%. So I have a third one as a keeper. Jill has 3 full-size pans of brownies. Each pan is the same size. She gave 3/8 of the original amount of brownie to her friends. She gave 1/4 of the original amount of brownies to her teacher. So nice. Exactly how many pans of brownies does Jill have left over? So this is going to require multiple steps. So first of all, we can figure out the fraction of how much she is given away. So what I'm going to do is I'm going to add up 3/8 plus 1/4. I'm going to make common denominators. My common denominator is 8. So I have 3/8 plus 2/8 equaling 5/8. That's how much she has given away, but the question is, how much does she have left over? So she gave away 5/8. We can just do simple math. We know that she has 3/8 left over. But that doesn't help us here, so we need to figure out how many pans. That's 3/8 of the original. So we have 3/8 of 3 pans here. And what I'm going to do is I'm going to multiply these together. So I'm going to do 3/8 times 3/1. Because I made my whole number into an improper fraction. I multiply across to get 9/8 pans. And that's the same as saying 1 1/8 pans left over. So here Kendra recorded the amount of water she used in 1 week. So 4 activities, and she was very specific with her amount of water in gallons. So you get 2 questions here. What's the total amount of water in gallons recorded for these activities? And the second one is how much more water was used doing laundry than cooking. And so what I'm going to do is I'm going to tackle this second one in this part of the video, but I'm just going to mention for the first one, add all the fractions. Add all the fractions. For the second one, we're going to tackle that one. Subtraction is a little bit different. So doing laundry, so she did 33 1/4 minus cooking is 10 3/4. So in subtraction, we need common denominators, which we already have. But my deal is I can't do 1/4 minus 3/4. What I'm just going to borrow from the whole. So 33 becomes 32. And then I'm going to 4 plus 1 is 5. So if I rewrite that, I have 32 5/4, which is the same as 33 1/4, minus 10 3/4. So I can go and subtract 32 minus 10 is 22. 5/4 minus 3/4 is 2/4. And I'm going to simplify that to 22 1/2 gallons. Leo is designing a circular tabletop with a diameter. I'm going to underline that key phrase here. Diameter is 10 feet. So question one, which is closest to the circumference of the table? Number two, what's closest to the area of the table? And so let's go ahead and do some math here. So number one, we know that circumference is equal to pi times diameter. So I'm going to do that math. I'm going to do 3.14 times 10. And when I go ahead and do that, it gives me about 31.4 feet. And option number C is the closest. So which is closest to the area of the tabletop? So the area is equal to the radius times pi. That's why I like to write that. So I need a radius here. So my radius is going to be 5. So what I'm doing is I'm doing 5 times 3.14. So it's the same as 5 squared. And when I do that in the calculator, it comes out pretty close to 78.5 squared feet. Give me option letter B. So the triangle represents a section of the garden. Figure not drawn to scale. Thank you, because we're dealing with meters here and my screen's kind of small. We need to figure out what the area and the perimeter are of this garden. So for area is doing the base times the height, and then we do all that first, and then we divide by 2. And so let's go figure out what the base and the height are here. So the base is all the way across. So that whole distance is 4 plus 13, gives me 17 meters. And my height is 3 meters. So we got some useful information. Let's go ahead and do our math. So I'm going to do 17 times 3, gives me 51. And then I'm going to go ahead and divide it by 2. So my area is equal to 25.5 meters squared. And then for perimeter, all I'm going to do is I'm going to add up all the sides. So side 1 is 17. Side 2 here, so this is I'm going to label it side 1. Side 2 is 13.3 meters. And then side 3 is 5 meters. And so let's go ahead and add those together. 17 plus 13.3 plus 5 equals. So my perimeter is 35.3 meters. Salesman sold 40 cars last month. Guy's a rock star. So the circle graph shows the results of his car sales by color. And so you can see here. So we have 2 questions. Identify the car color that most likely represents exactly 10 cars. So to get 10 cars, 10 divided by 40 is the same as 1/4. So I'm looking for 1/4 of my circle graph here. So I know it's not blue and not purple or red, so I'm identifying 1/4 here as the green section. So I'm going to most likely be the green section. So now I need to identify two car colors that most likely represent a combined total of 25 cars. So let's go ahead and write that out. So 25 over 40. If I was going to simplify that, I'd divide the top and bottom by 5, giving me 5/8. So 5/8 is a little tricky. If I'm going to draw a circle out, so this is how I'm going to solve this one. I'm going to cut it into 8 sections. So I'm going to start with halves, quarters, and then eighths. What I'm going to do is I'm going to color in 5 of those because I need to get an idea of how big 5/8 are. Okay, so it's a little, so 2 colors. First one I'm going to use is blue. And then I have choices here, so I can use red or purple. So I'm just going to put red in parentheses or purple. So saying is I'm using all of blue and then a little piece of red. So there's 5/8 right there. So in order to do this, I simplify my fraction, draw a picture, and then match it up the best I can. So Bob asked the group of people to identify their favorite vegetable. The circle graph shows the results. And you have this poor guy who likes asparagus. I don't know what's up with that. Which graph on the next slide could represent the same data? And so let's go ahead and analyze our data here. And so we notice that beans is the biggest. That should be the biggest bar in our bar graph here. And so automatically we can kind of take a look at our bar graph. So we have beans, beans, and then beans. So we're going to eliminate the middle graph first. Let's go and eliminate that one. So our smallest section is asparagus. So I'm identifying the biggest and the smallest here. So amongst the two, asparagus, that's the smallest on that graph. And that's the smallest on that graph. Next up, let's go ahead and look at, so in this graph, carrots and broccoli are the same size. So when I take a look at carrots and broccoli, they are not the same size. So I'm going to cross that out. So here I have carrots a little smaller than our broccoli. And then corn's a little bit bigger, so I can say that this is the third graph. So you can see how I kind of talk through that. Start with my biggest piece, work at my smallest piece, and then kind of start to make comparisons going around. Jill recorded the number of pull-ups each of 10 students did in the line plot. So we know that there are 10 X's. So there are 10 students. What is the balance point of this data? So anytime I see balance point, I'm figuring out what the mean is. So in order to do this, there's 2 ways you're going to do it. I'm going to show you the one where you just add them together and divide by the total number of X's first. So let's go ahead and add up our X's. So you have 1 plus 1 plus 2 plus 3 plus 3 plus 1, 2, 3, 4, 5 plus 8 plus 8 plus 8 plus 8 plus 8. I'm just writing them all out. So so I have 2 plus 2 is, so 2 here plus 2 is 4, plus 6 is 10, plus 40 is 50. So I have 50 here, and I'm dividing that by the total number of students, 10 students. Means that my mean is 5 pull-ups. That's the adding way. So you add them together and divide by the total number of students. There's also a way where I can move X's. So what I can do is I can start in this end, move my X here. I move my X's closer to the middle. I start with the outside one and I move it. Start with the outside one and I move it. And you just keep on repeating that pattern here. Some of you really like this because you like to cross stuff out and draw all over your page. So you can see here that I have 5. I can move 5 at the same time. if I can move 5 here at the same time. So I can 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And you can see right now that I'm getting closer and closer to 5. So these 5 x's are going here. And then these guys are going to move here. So you can see how they all stack up on 5. So you can draw this out and it'll help you out. Andy surveyed his friends to determine the number of books each of them read in February. Here are the results of the survey. Question number 1 is, what is the mean of the data set? So the mean is what we're going to do is we're going to add them together. So we're going to add up these numbers, and when we do that, so it's 3 plus 2 plus 3 plus 19, ambitious one, plus 2 plus 1 plus 2 plus 2 plus 2 plus 2 equals. So 38 books, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 students. When we divide that, the average is 3.8 books. So if we're going to find the median is when we line them all up and find the middle number. So line them up least to greatest. So smallest number is 1. And then we have a bunch of 2's. We have 1, 2, 3, 4, 5, 6. We have 6 2's. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Double checking. We have 2 3's, 3 and a 3, and then a 19. So I got my numbers. And what we're going to do is we're going to find the middle number for the median. So I start the edges, and I just cross out until I find my middle number here. So I have 2 middle numbers. They're both the same, so I add them together, divide by 2, gives me the median as 2. And is mean or median a more appropriate measure of center? So I'm going to say median is, because 19 is my outlier. You have one student read 19 books in a month. Everybody else read between 1, 2, and 3. So 19 kind of messes with the data a little bit. So I can say that median is a better choice than finding the average here for this data. So we have 4 questions here. So we have to figure out what's the common ratio of the sequence. So common ratio means I'm going to be multiplying by the same number. So I know that I'm multiplying by 5. So I can say the common ratio is 5. What's the common ratio of the following sequence? So you see that my numbers, it's the reverse of this. So I can say that I'm multiplying by 1/5. So I would also say, you can also say the same as dividing by 5. But when it's just asking what the common ratio is, we're just looking for what we're multiplying by. So that's why you have to use 1/5. What's the common difference of the sequence? So common difference is I am adding. So I'm adding 3 to get to the next number. And the other one is I'm going to be subtracting 3. And so the reason why this one works out is because subtracting 3 is the same as adding a -3, which you'll learn in 7th grade. We want to solve each equation here. And so here we have one-step equations. And we have to figure out what the variable equals in each situation. So for my first one, for number 1, 2 times a number is going to give me 4.8. So the way I solve this is I divide both sides by 2. And in my calculator, since you are allowed to use it for this one, I can say that x is equal to 4.8. 4.8 divided by 2 gives you 2.4. So for number 2, I have m divided by 2 is equal to 4.8. And to get m by itself, I'm going to multiply both sides by 2. So I'm left with m being equal to 4.8 times 2 gives me 9.6. I'm going to save 3 and 6 for last because those are fractions. So let's go over to 4. 4c divided by 6 equals 0.6. So I'm going to multiply both sides by 6. I'm just doing whatever the opposite of the operation is. So I can say that c is equal to 0.6 times 6 gives me 3.6. And then for number 5, I need to do the opposite of subtracting 6 is adding 6 to both sides. So I can say that c is equal to 6.6. I have 2 more problems left here dealing with fractions. And so I have c plus 5 and 5/6 equals 8 1/4. So what I'm going to do is I'm going to subtract both sides by 5 and 5/6. And then you're going to have to do your math to solve that. And number 6, so you have x minus 2 and 4/5 equals 1 and 7/8. So I'm going to go ahead and add 2 and 4/5 to both sides. I'm going to get my fraction.